Hello everyone, and welcome to my virtual session entitled Hello World, Hello Math. My name's Adam Bishop. I'm a teacher at Lakecrest Independent School, and I'm also an educational designer at Clockwork Fox Studios, a company that makes Zorbit's Math Adventure. I'm here to talk to you today a little bit about how we can really enrich our math class and our math instruction through the use of coding in our math classes. So a little bit about myself. I've been teaching for about 18 years. I've gone from kindergarten on through university. I've been a teacher. I've been a math coach. Currently, I'm an educational designer with Clockwork Fox Studios and spend a lot of my time thinking about activities that can be used in the classroom successfully for a whole range of students. I'm also married and father of 3 girls, which is important because, as you'll hear, this idea of doing coding in the math classroom really opens up your class to all sorts of learners, all demographics, all ethnicities, and all genders, which is very important to me personally. I saw this need to encourage my children, my girls, to understand that technology was something that was accessible to them and that it was an area, if they were interested in, they could certainly pursue. And incorporating this became really a passion project for me in a lot of ways. After teaching for about 10 years and seeing the potential of coding, I went a huge step and went back and studied computer science at university to really examine ways that we could easily implement this in classroom environment and really drive our math learning, which is what I'm going to talk to you about today. And as soon as I stopped teaching in college, I was really that sage on the stage type teacher, that stereotypical get up, lecture to my college students. When I made that transition to middle school and understood that that wasn't what I needed to be doing, I immediately started to teach coding. I've completely changed my classroom environment, and it's really opened up learning pathways for students that I had unknowingly closed off before. So here's what we're going to talk about today. First, we're going to address the concerns and challenges that I'm sure that you have when you signed in here. If you signed on to learn about coding, we're not really going to do that. If we were in a one-on-one or in a small group setting, we would talk a little bit about coding and how we could learn those first pieces in the classroom. But I want us to focus on using coding as a tool to push our math conversations in class, or to encourage our math conversations in class is probably a better word. So what we want to do is we want to use coding as our tool to have really rich, engaging conversations with our students. And I'm going to show you and explain how we can do that, looking at programming with our youngest learners, operations with elementary math students, some triangle examples in middle school, and finally algebra in high school as just the backbone of how we can drive these conversations through coding. Then we're going to go through a few how do we get started, what do we do now type tips. And finally, I'm going to share some resources. So these resources at the end, these are all free resources. These all have a great tutorial feature that will guide your students and you in getting started coding. So let's address these challenges, and that ties with those resources because, like I just said, each of these resources has these built-in tutorials. I'm not saying you need to know how to code before you can go do any of this in your classroom. As a matter of fact, you don't need to know how to code anything. You need to have access to the resources. You have to have the willingness to give the reins to your students and let them drive this and kind of navigate them to the right places, and then kind of step back and just have conversations about the learning and about the math, and the depth of understanding is just going to take care of itself. So don't worry if you can't code. The resources that will come to at the end will get you started in those areas and show to you how you can get your students started. So we've taken care of the know-how. You don't need to know how to code. That's not the point here. The point is use the coding to have those math conversations. Technology, obviously a concern. We're talking about coding. Need computers, need internet. Well, we're going to start in lower grades with actually not using any computer. We're going to do offline activities. And I'm also going to suggest some ways that we can do that in middle school and high school as well, so that we can take care of this even for our students that don't have computers at home. If we don't have one-to-one devices in school, some of the programs I suggest actually have tons of offline resources. I'm going to share a couple that I helped create at Zorbit that you can also go get. So there's lots of things out there that you can use that don't involve technology. So we'll take care of that one. Time, huge concern. We have to get through our content. We have a ton of math content already to cover, too much in most cases. Well, not only is this eventually going to save you time, but it's actually going to be a cross-curricular thing. So this is going to blend into all your other courses too. So in the long run, this is actually going to save you time. You're going to get more done at a much deeper level. Your students are going to leave with a better understanding. And yeah, the startup is going to take some time. Kids are going to take that week or 2 weeks that you might be starting a topic, and they're going to be playing with coding or playing with Scratch. But you're going to make all that up down the road. So you're going to see that this is actually time saving in the long run and so engaging. Difficulty, of course, this is hard. You say the word coding and people instantly panic, but the kids love it. They jump over each other to try to get to work on these sort of things. And the difficult part is really just getting going. Once you get started, you're going to see they kind of take over and you get to be that guide in the background who's kind of just going. You're chatting with students about their math. They're struggling with the code, but what you're seeing is how they're thinking about those math processes. And that's really what we want to focus on, is this is our tool to get at what the students really know and give them another choice in how they want to present their learning. There's a ton of benefits to using coding in your classroom to have these conversations. It's engaging. So you're having a conversation about the coding, but you're listening to all of this learning that's going on. And the kids are so engaged in what they're doing that the conversations just flow naturally. They're motivated to keep going. They get to be creative. There's so much fun happening in your classroom that it almost looks like that free time environment that you might create. But here's your standard everyday math class. By learning the coding, they're also getting skills they're carrying over to science class, to French class. So beyond the math classroom, they're getting to use some of the things we'll talk about, like Scratch, like Python, like website development. There's also tons of new opportunities. Learning this skill will open up doors for them right away and sometimes down the future. And I've seen that from my own students that I've exposed to coding. It's turned into a career and scholarships and all sorts of different things for students, which is great to see, but just giving them access to a different way to think about things and the choice in their learning. And finally, the social emotional context in their learning is huge here. We're breaking down barriers, we're building up confidence, we're giving students a new way to express themselves. We're giving them this resilient attitude, this mindset that they can keep working at it, and it's worth the struggle. That productive struggle becomes natural when they're working in coding. And all of these are the things we want in our math class, and the coding is just going to be our tool to drive them in that sense, which is very powerful. So a lot of this thinking really is based around this, I'll call it a new design for math class. And really these are just things that we look for when we're designing a video game. We want action, social, mastery, achievement. These are kind of categories that we want our users to experience. Well, why can't math class be that video game environment? We can create this action, this excitement, this drive to really want to be successful, this social collaborative element, this achievement of, yes, I got this to work. Yes, I got this to work. Oh, I have a bug. I fixed it. And these celebrations, you can watch kids in math class jump out of their seats because they've managed to accomplish this thing. And all the while you're going and you're there and you're saying, wow, that's so cool. I can't believe you did that. How did you decide to do that? And you have these conversations and they're telling you about all the math and how their code worked, but they have to understand the math so well to get there. So that's what we're using this for. It's that ask the question, what is that next thing you want them to know in the math? And it's hidden away in that code and they just explain it to you. And it's such a well fit together piece. And of course, that immersion is their interest in driving in there. They just dive or jump in there feet first, and they're so gung-ho to try it. And then they get to be creative. So they pull all those pieces. And when I talk to my students and ask them about what a math class looks like, they don't tell me any of these things. But after they start to code and they start to use coding as a way to communicate their mathematics learning, this is what math class can look like. And it's a complete mind twist for them because all of a sudden they can't wait to get to math because it's so much fun. They get to play with different things, and yet their depth of knowledge is so much bigger, and there's so many rich conversations that happen. So let's start talking about what these can look like. So first we're going to look at primary classroom. So if you're a primary teacher listening to this, you need to start small. You might have 4, 5, 6-year-old students, maybe a little bit older. Coding is not something you just want to say, here, start typing on the keyboard. So we have to take baby steps here. If you're lucky and maybe another teacher has done this and they have some exposure, maybe you can jump in a little bit higher. My suggestion is to start thinking about things like mapping, location, counting outcomes. Those are ones that really lend themselves well to a lot of these platforms. So when I say platforms, I mean the different tools that we can use to code with. There's some specific relative position outcomes, and I just listed the common core objectives, but these exist in all curricula across Canada. Adding in grade 1, and we'll look at an example of that specifically, some mental math tasks in here. So in my class or in classes that I go help other teachers, this is how I get started. I start with a math talk. Then we move to an offline activity. So here we can spend 2 weeks, 2 months, never touch a computer and develop all kinds of computational thinking. Teachers don't need to know how to code. The examples I'll show you are actually things you can fully download that don't need to be changed, that have the questions. Everything is there that you can just take and use as is. You don't need to know anything else beyond what you know right now. So this is a great starting point. And all of a sudden, your young learners are already computationally thinking. They're explaining their reasoning. So these are great. Then we can move to Scratch or Scratch Junior, which are free online platforms where kids can code on a tablet or on a Chromebook. There's built-in learning tutorials that they can do, and I'll share with you all the addresses to get to this stuff at the end. There's also built-in tutorials for teachers, lesson plans. There's an unlimited wealth of information there. So easy to get going. So with a math talk, this is a typical technology computational thinking math talk that I've created and that I use, and that you can grab from the website at the end. And you'll notice it's simple: step forward, turn left, turn right. What we're looking for here is students to explain their process. Kind of think like an algorithm, like what is the direction I need to go? Be very specific. How many steps forward do I need to take? So now we've started to talk about counting. Maybe we want to say, can you go on each of the numbers or each of the colors, sorry. So now we're talking about different pathways. And is one path longer than another pathway? And does someone else have a different answer? All the while this conversation is happening in class, you're recording these answers up on a smart board or on a whiteboard. Maybe kids are writing on their own whiteboard how many forwards, how many turns. And then we can kind of lead the conversation anywhere we want. And we can talk about pattern. Can you find a pattern to get to the star? Was there a pattern in your moves? Was there a pattern in the colors? We can count about how many moves. Can you take more moves? Can you take less moves? So there's all these ideas that are all important math things. They're all in your curriculum. What's a bigger number? What's a smaller number? What's longer? What's shorter? And here we are just having a conversation. It's creating this ability to step-by-step algorithm, which is that computational thinking piece. No technology piece needed, but we're starting to develop these coding skills in our students. I've actually done this with middle school students just like this, just as valuable, just as good of a conversation. So there's no reason this has to be limited to our younger learners. After that, we can move to an offline coding activity. So this is more of a game. It's a little bit more elaborate, a few more pieces. We're kind of playing as two players in the game. We have a robot player, we have a controller, and we're giving, again, those same sort of instructions. Maybe we throw in some repeats here, some start and stop places, some targets along the way. All the instructions are there, and you'll be able to download those at the end. But the idea, again, here is, what is the math conversation? Are you looking for patterns? How long is your path? What are some of the steps along the way? Do you see a piece that could repeat? Can you add 3 more pieces to get there? And having that conversation, getting students thinking about that, they're inherently thinking about, oh, you know what, I can do this faster, or I can do this slower. There's so many pieces in there that they're just having these thoughts, and you can just go around the classroom. They're having a great time. This is very kinesthetic, so you're getting those students up moving. But again, it's that computational thinking piece to drive the conversation in math. And that's the focus here. Use these ideas to get in there and have talks with your student to enrich that math understanding. It's just layering levels onto what they already know because they're thinking about it in different ways. And here is a great example of what a grade 2 student actually put together for me. So if you just watch the ballerina, the grade 2 student wanted the ballerina to move up and down a little bit. And she managed to figure that out. So this was in a classroom where the teacher had traditionally given a worksheet. So a typical addition question for this girl was just a worksheet of 4 plus 8, 7 plus 3, and just fill them in. And we've all seen that classroom. Some of you might be that classroom. I certainly was at one point. So that's okay. But what this did is this managed to kind of make that little girl not be really interested in what she was doing. Math class was boring. She was only writing this down. So after spending a couple of weeks working in Scratch, so this is the Scratch environment, I asked her to say, can you take some of the things that you know and maybe make a question in Scratch? And this wasn't an overnight process. This took time, but she started to think, well, I wanted to just ask me numbers. And this wasn't her first version of this program. The first version was simply say the number and say another number. So she just hard coded 1 plus 1 equals. And eventually she figured out how to get the answer to go in there. All the instructions were in Scratch. She had done tutorials. Then she started to want to make it so it was different questions every time. And so she added this random number piece. So the whole time, she hasn't really thought about math. All of a sudden, math is fun because she's got a disco ball and a ballerina dancing. And now she's figured out how to put in these random numbers. Now the teacher sits next to her and she answers these questions that pop up, which are different all the time. On this GIF, you can see they're repeating. But every time this child plays this, they were getting different questions. The teacher's watching her enter, no problem with her addition facts. Teacher can ask questions to extend that knowledge. But now we've replaced that worksheet with this super creative product that's mimicking exactly the same task that the student created themselves. Now you can talk to them about that. How much that student knows, both in technology now, but also understanding and thinking about what's going on, is so much deeper than what it was before. And that's a grade 2 student. So let's move to elementary school and see what some of the things that these students might do that's a little bit different. So in elementary school, the operations strand is a wonderful starting point. And I say that because computers are really powerful when it comes to just repeating operations. So getting students started with some outcome that ties into operations. Typically, if my students have a little familiarity with coding, I try to pick the things that they complain about. So something that is just, oh, this is boring, I can't do this anymore. That's the stuff I tell them, well, you know what? You don't have to do it anymore. Make the computer do it. Figure out a code to do it. And all of a sudden, you see a switch in these kids because they just rather be on a computer. You look at today's world, getting that instant gratification, that feedback of doing things is so important. So I'm just trying to make the math class more like that. And it kind of hooks them in right away. So all of a sudden, you ask them a question and say, go do it on the computer. Their mindset is different. So if you get them in a positive mindset, their learning becomes so much better. It's just so much more to what they're doing. So if they're struggling a little bit and they maybe can't quite reach what I might want them to in my curriculum, maybe I ask them to support younger students. You know what? It would be really helpful for me if you went and you took an activity and you made a simple addition activity for the grade 1 class because they really need to practice their addition facts. And getting that framed in the idea of, oh, let's go practice, let's go make something that's easy for younger kids. They're also still learning about math. If you've ever run a peer tutoring group, you'll realize that getting kids to teach other kids about math is one of the most powerful ways for them to develop their own depth of understanding. Well, the same thing works here. If they make an addition program for 2 grades lower, all of a sudden their understanding of addition and place value is right where you wanted it to be anyway, because they've had to think about things on a level that is not really what we typically anticipate. So it's really a great way to drive them to where you want them anyway. And in their head, they're just doing stuff that's easy anyway. And so again, it's that mindset battle. They've already done more. And again, you're looking at what they're doing and having those conversations about what they're creating. And that's where that math piece comes in. So two outcomes that I'll show you examples of are some factor pairs. So looking for factors of a number, super repetitive task. Every time I go through this, kids complain about it. If they were doing factors of 60, all right, now find factors of 80, now find factors of 100. And nobody, it doesn't matter how much you like math, having to do that repetitively is not fun. So that's a great first one. It requires a little more thought, but great conversation. And then just multiplication. If you look at a lot of curricula across North America, the idea of understanding the standard multiplication algorithm is there. If you can understand that algorithm and write a code to do it, then maybe you don't have to do this practice sheet. So that was a challenge I put to one group of fifth graders. And what they managed to create, I've got on an example coming up. So Scratch is still my go-to, just like the addition facts for the grade 2 girl. It's still a very user-friendly, creative environment that students get drawn to because of the graphics and all the flexibility. So it's still the first thing that I'll use, especially if kids have no coding experience. Start there. If they do have a little bit of coding, you can jump to that last one on the list, the HTML and JavaScript. If you get kids and they want to start making their own website, there's tons that they can do in HTML and JavaScript. So there's some references at the end of this document as well of some places they can go get started in that, and some free learning that is good for teachers, good for students. And I've had students dive in here as well. They'd have to have some exposure though. And then there's that pseudocode piece in the middle. So what pseudocode is, if you don't know, it's purely just a handwritten version of code. So instead of actually typing it on the computer, especially if I don't have devices for everyone, I'll say, you know what? Write it down what you would do. What would you tell a computer to do? Or what would you tell a robot to do if you wanted the robot to accomplish what we're working on? And having the kids write that out in what I call robot language to them is really powerful, because you start to see them think, well, okay, that worked for 2, but does it work for 3? Does it work for 4? What if that number's bigger than 4? How big will that work for? And all of a sudden, those wheels are going, and I'm there asking questions, or you'll be there asking questions to guide that thought process. So here's I believe this is a 4th grader who created this one. And you'll start to learn when you play with Scratch. You can start to give students assets for the backgrounds. So every time I get them to explain something, I kind of use this chalkboard in the background and kind of pretend there's this teacher element to it. And especially if I try to make things for younger grades for them and kind of pretend that that's them. And students get creative with it and change it, but a lot of times they'll keep that same type thing. So this student, as you can see, they figured out how to put the factors of a number. Now, what's awesome, if you notice as these examples are going by, it doesn't perfectly give the factors. It gives the correct factors. The code is awesome. But the whole class, we spent about 3 days as a class talking about why, when we had 25 there, does it show 1, 25, 5, and 5 again? And then when we try a number like 12, which flashes a little too quickly for you to see, it actually repeats all the factors. So all of a sudden, this class went from, here, find factors of 60, 80, 100, to why does this code duplicate all the factors of 12 and then duplicate just those repeating factors for 9? And what do those repeating factors mean? What does that mean about the numbers? And we went way beyond the scope of a grade 4 classroom here, and the level of understanding across the board in the class was absolutely phenomenal. Here's another, this is the grade 5, and this grade 5 student, this was the only student that did this in the class, and they were very much, oh, math is boring, I don't want to do this, we always have to do the same, you just have to do the same thing over and over and over again, which I'm sure you've all heard. So what I did is I said, okay, you know what? You don't have to do any more if you can get the computer to do them all for me. And the reaction to that is typically, how am I supposed to do that? Or, yes, let me do that. So in this case, he just started in Scratch. And if you will look through the example, it's not quite the standard algorithm, but there's so much math here that one-on-one we sat down. I didn't go through this one with the whole class, but you can see on the right-hand side in that text there, there's some mod operators. So that's division with the remainder of division included in there. And he had to think about place value. Now, he had to come ask me, what's a mod operator? Because he had done some Googling, trying to figure out how to isolate place value so he could multiply just the 5 or just the 1 from the 13 times 15 example. And he looked in that, he found this operator, didn't know what it was. That was a conversation we had. Then I could ask him, well, why do you need to know that? What is the place value? What is the purpose? What are you trying to do here? And he started to realize, like, he had to multiply the ones by the tens, and then the tens by the ones, and all those different place value multiplications. And those are the pieces that he filled in, the add at the end. And then he put that answer there as a, can you multiply and check your answer? And again, the code worked. There's lots of things we could fix in the code, but the conversations that came from it pushed his level of understanding to another level. He didn't need to do worksheets on multiplication. He knew how to do the multiplication. Now he knows it even better. That's your purpose here. In middle school, same idea can be accomplished, but my first reaction I get in middle school all the time is, if I'm coding, I want to do a video game. 100% of the time, they want it to be a video game. It can't be a video game right away. But we can mimic a lot of the experiences that come from video games. Like I kind of went through why I changed the design in my class. Again here, starting simple, adding those multiple grade levels below is fine because it's getting them to think at a level that's back to where they need to be anyway. Get that creativity collaboration element in here. Bug fixing in coding is what I equate to celebrating our mistakes in math class. It's celebrating that mindset of, you know what, it's okay that this is not right because I'm going to work at it and work at it and work at it until I get it. It's developing that grit of, you know what, I know I can figure this out, and when I do, it's going to feel awesome. And I have literally seen kids jump out of desks when they figure it out. And this is kids solving math problems. So I want you to think about that. Visualize your math class, how it typically goes, and imagine a kid being so excited when they're done something that they jump out of their seat. And that is not uncommon when I'm going through these with classes. So operations is a great starting point again here. It's that repetitiveness in a computer becomes so powerful. Take advantage of that. If you're getting into exponents, great way to introduce a ton of concepts in here. Get them to try to just solve an exponent on a computer. And there's tons of conversations. Well, maybe the number's too big. What's too big? Why do we use powers in this way? Tons of little conversations you can have there. Geometry is the example we're going to look at because it's kind of a weird one. If kids are already a little bit into the coding piece and you can take it to another level, geometry is interesting because we can use that HTML, CSS, JavaScript listed there to really create interesting visuals. That's a different, you'd want your students pretty comfortable with coding at that point. But we can also talk about shapes and what they mean in a less visual way, and really get some really good understanding. Here, if students are already comfortable, I've gone with Python historically. So Python, I've got some sources at the end. I just let students go free on it. I have never coded in Python until I gave students access to this resource. And so this was completely new for me. And I said, here, you go learn it. If you want to learn it, that's fine. Then come back and show me how to do something. And they drove me to learn a bit more about it. Scratch, again, still great in middle school. Still has that creative element. They love it, hands down, all the time because it hits that video game dynamic a bit better. And then, of course, the website that I already talked about, that HTML, etc. piece. So here's an example. This was done just a couple of months ago. Well, I guess a couple of weeks ago, sorry, by a student in one of my classes. And we're looking at triangles. And they were sick of trying to figure out triangles. Is it a right triangle? I just don't care if it's a right triangle. I don't want to figure any more of these out. I said, well, you've already looked at some of this coding stuff. And we talked about how far he had gotten in looking at it because it was an area he'd been interested in. So I told him right at the start of the year, you know what, look into this. We'll see if we can use it. And he had told me he'd gotten a little bit past conditionals. And if you're not into coding, that's that if statement. That's that control piece. So I said, you know what? Instead of actually solving any more of these, do you think you could write something so that our whole class can just answer all these questions really quickly? Because, yeah, right, this is taking a lot of time. And so putting that challenge on him was the first step. That got them super interested. So once I had them interested, it was that idea of, okay, we're answering questions about right triangles. What does that mean? What do you need to learn about that triangle? So all of a sudden, Pythagorean theorem is the thing that pops up. And So that's what you see here, entering the lengths of the sides of a triangle. The GIF is a little bit fuzzy for some reason in the slide, but the code is pretty clear there. So that line 7 is Pythagorean theorem rephrased so that it can be used in a computer. So we talked about what that meant, and we talked about it as a whole class because we were narrowing in that right triangle piece. They actually went a step further and looked at what that would mean in terms of other angles. Now, there are problems with this as a code, but as a math process, this was such an eye-opening conversation. They took more from that than me writing Pythagorean theorem on the board and talking about what it means to be a right angle and how Pythagorean theorem works and what does the squared mean and what does the hypotenuse mean. All of a sudden, all those pieces are in this piece of code, and we dissect that and why did you make that decision, and understanding is so much deeper. And since that code piece is already there, this is where you're getting that time-saving element. We've saved time because now we get through this so much quicker with way more understanding. And finally, we have these high school examples. So the first issue, and I say issue, I say it in a good way, is a lot of high school students who've already used this a little bit will want more power. They're doing more abstract type topics, so they want more abstraction that doesn't exist the same way in Scratch or is not as easily accessible. So typically with high school students, I've used Python, I've used JavaScript, HTML and CSS quite a bit because they like that design element of websites. Scratch, if a high school student hasn't touched coding, Scratch is still perfect. It is a great, great, great free tool. I can't emphasize that enough. If nothing else, you leave here, you go try Scratch, and you show it to your students, they learn it, you talk about math when you're doing it, then this was worth your time because you will become hooked. So to get back on track, if there is another language that you're interested in, I have tried other ones. In high school, I tend to be a lot more open with what I let the students do. So if there's something that they're interested in, they've read about Java or they've read about Objective-C or they want to learn how to make an app, then I let them kind of take the lead on that. And again, the idea of let them learn, they can teach me about it. And the whole time we're just talking about math anyway. So what the language they're writing those other pieces in doesn't matter to me. As long as they can explain why they did it mathematically, I'm very, very happy. So this next example I'm going to show you, this is a student that really took this to the next level. The topic we were studying was factoring trinomials. And the idea of factoring a trinomial is pretty monotonous once you get to the point where you're just factoring it for the sake of factoring it. If you look at textbooks, there are pages upon pages of pages. Do this, do this, do this, do this. Now, there are other ways to make it interesting, of course, but my challenge was, you don't want to solve any more of these? Make me a computer program that can solve them. Off they went. We had just barely introduced the idea of factoring these. Certainly the A value, if you know what I'm talking about, great. If you don't, no loss. You're not going to be any further behind. That A value was only equal to 1 at this point. So this student goes off. It's high school class, so a lot of flexibility. They come back with this written. So if you notice here, there's 3 buttons that you click on, what kind of questions you want, if you want negative numbers or not, and then how many you want. And this was the result of that, is you click on get 5 questions, you get 5 questions, in this case with negatives. You get to type in your answer. The answer is checked once they're all typed in, and it tells you what's right or wrong. It also tells you what it should have been. So basically it's a digital worksheet. So I would never encourage, here, take this digital worksheet and go do it. But if you can make the digital worksheet and you understand how to fill in all those pieces, you be my guest. And that is ultimately what I'd love to get every student to get to, is don't make the worksheet, or don't do the worksheet, sorry, make the worksheet, code the worksheet. How are those questions created? How is every single question solved? And you reproduce that, then you understand this better than you're ever expected to understand it. So here's the code that the student actually produced in this case. And this is a little more elaborate than we really need it to be. But I just wanted to highlight here. These are things that I could sit down and talk to the student about. Why did you make these decisions? What do all these pieces mean? Because remember, I don't necessarily know how to code all these things. They're showing me languages I've never seen. They have to explain the steps here. So explaining the math, this idea of greatest common divisor, that GCDI piece. Why are you removing the negatives? How are you dealing with common factors through the trinomial? Are you starting with the factored form or are you starting with the non-factored form? How are you working that out? How is it generating these? That math conversation is richer than any you can have about how do you factor x squared minus 1. So this idea can really motivate to the next level. So what do you do now? So that's a lot of talking. I really wish if we could have been in a classroom and we could have narrowed in on a topic and played with it a little, done some math talks, you could really have sunk your teeth into how coding can enrich your classroom experience for you and for your students, but we're not. So this is what we got to do now. You just got to go out there and do it. It's scary to try something new in the classroom, but I promise you this will move your level of understanding of your students beyond where it currently is. I have yet to see a student regress because they tried something different. They're looking at things in a different way. We as teachers inherently want them to look at things in different ways. Coding will allow them that opportunity. And there's so many perspectives. We're not focusing on the answer. We're focusing on building that process. What is that process? That's what we're building. And that's so important. We're focusing on that journey here. So get started. Focus on how we're going to get to the answer. Not the answer. The answer may or may not be right. The code may or may not work. But how are you trying to do it? Where's that math conversation in there? That's what I want you to focus on. Start small. Don't be afraid to just give them access to these tutorials I'm about to show you where they are on Scratch and say, you know what? Go design a house. Go move Scratch from one side of the screen to the other. Get Scratch to do a twirl of 360 degrees. Oh, what do you mean you don't know what 360 degrees is? Well, let's talk about that for a second. What if we only did half the circle? What does that mean? And all of a sudden, now we're just getting started. Simple task in Scratch. And now we're already talking about rotations and angles and circles. So just go get started with a small conversation like that. Use Google. You start Googling how to do something in Scratch, how to do this in Python. The answer is out there. Don't be afraid to look for it. When people code, they look for hints, ideas. There's tons of blogs online about using different pieces of code in different ways, open source things. It's all out there. Just type it in. Also, don't be afraid to harness the power of Twitter. There's my Twitter handle. Feel free to follow me and send me a DM. If there's any questions you have, I have received DMs from teachers of some of the things that I've posted asking me how could they implement these in their classroom, and I've sent them lesson plans. If I have something that will help you, I will certainly let you have it. But there are tons of educators out there trying to promote not only coding, but yeah, follow them too because you can learn a lot. But the idea of how you can harness it to have those better math conversations, because that's really the takeaway from this. Not that everyone needs to learn how to code, but that using coding makes math learning so much more engaging, so much more rich, so much more fun, and so much more accessible. That's the takeaway here. So the reason we all teach, for me, doing this, is through these three students. Now, there are tons of stories of students, but I had to put these in there because these are three students that started with me the very first year I started doing coding in the classroom. I didn't know what I was doing. It was kind of like, here, go learn how to do this. And if you learn, you could really explain it to me because at the time I had never even heard of Scratch. It was completely foreign. But I said, here, this is a new website. Go try this out. And this was, I taught one of these kids for 2 years, one for 3, one for 4. They were awesome students. None of them at the top of the math class. When they all graduated or left school that I was at, all the top marks in math. They went from they did like computers, one hated computers, to all of a sudden this accessibility, creativity, this new way to look at things completely opened doors and new avenues for them. All three are now studying at very prestigious universities, computer engineering. I've still been in contact with them, and I've received tons of messages from them because they're so excited that they got to see this different thing that they never even thought about. give them a different avenue, give them a path that maybe they won't see if you don't open this new opportunity. Here's these resources I've talked about. So Zorbit's Math Adventure, coding activities, there's the website. You go there, there's offline activities to download, Math Talks, the visual that's there, there's a bunch of those visuals you can download. So those are things you can just go and use offline in your classroom right away. No technology, no prep really. You might have to cut some things out, but the questions to use there, how to enhance and extend and vary the activity, all that's there. Scratch, you've heard me talk about a lot now. Go to the Scratch website. It's free. Click on the Learn button, click on the Teach button, and get started. Try to make something, and instantly you'll be able to see how that turns into math conversations in your classroom. Scratch Junior, if your students are a little bit younger and you're kind of afraid that Scratch, when you look at it, might be a bit too hard, if you have tablets, Scratch Junior is where you should go. A little more graphic, no words that to read. It's all visual, and really good stepping stone if you think Scratch is a little bit too hard for your students. And then on down the list, Python, JavaScript, Code.org, Code Club, and Canada Learns to Code provide training, support for students, for teachers, lesson plans, all kinds of things there that you can instantly take as is. Some of them have built-in rubrics. Take them to your classroom. Students can learn the code. You make a little twist and you say, now you do it, but you make me a math problem. And all of a sudden, you've taken everything we've talked about, and I promise you, your classroom will have this new flair to it, this new energy, and the students will be excited to be explaining all these math topics to you in this new fancy way that they are going to be working on things. So hopefully you go now and you type in that Scratch address if you've never done it before, and you try some of these things out. And thank you very much for joining.